Hey, welcome back. Today I got something a little different from my usual repair videos. I had my wife, she went into a little bit of panic there because she couldn't charge her cell phone, and she had some ads posted on Kijiji that she was, people were responding to, and the phone was going dead, so she had a little bit of panic mode there. So I looked at the phone. I says, I hope it's not another battery, because I just replaced the battery, a 3 months ago, I think, and the phone was working great after that. But I went and looked at the phone and I plugged it in, and usually you get a little chime when the phone's connected to the charger, and this time it didn't do anything. So I got suspicious and I got the charge doctor out, and I checked the phone charger. And to my surprise, this is lit. I don't know if you can see that. It's powered because it's got a neon bulb inside, but let's try this charger on the charge doctor, and we'll see what's going on here. And we got absolutely nothing. Nothing at all. So that's no big deal for me. That's no big deal because I got 5 or 6, 7 other charges laying around that I just replaced it with and carried on. But that's got me thinking, like, what went wrong inside this little charger? It's a Sony. It's original Sony charger. This is a UCH20, and it has an input, a wide voltage range from 100 volts to 240 volts. So it's national, 50-60 hertz, so it doesn't really matter what you put into this for power, and it draws 200 milliamps, and on the output side we have 5 volts at 1500 milliamps, so it's it's a capable charger. And but I think we're going to open this up and see if we can repair it. And now you're probably wondering, why the hell would you want to repair one of these things when you just toss it aside and get another one? Well, how else are you going to learn? It's got a tiny little switch mode power supply in here, and I find those interesting to repair. There's always a little bit of a challenge involved with repairing switch mode power supplies. You got multiple things that can go wrong, and we're going to open this one up, hopefully, and see if we can do anything with it. And if we can't, well, at least we tried. One thing I noticed, the output here, if you smell it, it smells burnt. I can smell a burnt smell coming from inside here. So in the last few days or day or so, something happened. Maybe a power surge. I don't know. But this thing went kaput. So let's try opening this up. And from what I can see, the only way to open it up is on the back here. There's a panel that's not, like, this is all one molded piece. So this is the only piece that's separate. So I'm going to try popping this off and see what I can do here. Maybe we can't open it. They don't make these easily openable because they're not supposed to be, oh yeah, it's glued. They're not supposed to be repaired. Usually for safety reasons. They don't want people repairing them. But here we are, we're going to do it today. So let's see what we can do here. It's holding on the sides very good. Just want to stab my hand. Okay, I can get this end off. There we go. We can re-glue that back in. It's a little bit scarred up now, but how do we get this out? This might be a problem. Oh no, look at that. Wow, so we got a little circuit board. Let's take a good look at this. We've got our power input here on these two. And we have a fuse, which looks like it might be a 1 ohm resistor. brown, black, black. Maybe it's a 10 ohm resistor, I don't know. You got some Chongx capacitors. 2 Chongx capacitors, and we got another these two are on the input side. There's a divide line here for the isolation. So we got power input, fusible resistor, goes straight into a little tiny bridge rectifier, and then from there it goes up to this big cap, and this cap is a 4.7 microfarad at 400 volts. And then from there it goes into a little circuit. This chip here is probably a combination MOSFET and the charging circuit. A couple resistors, another resistor, a diode, and that's pretty much it. Another capacitor on top, another diode. On the output side of the transformer, we have a diode. It looks like it's really roasted here. It's baked. We have 470 microfarad 16 volt filter cap. That goes, it's got a discharge resistor again across it. There is no feedback on this. Oh, hang on, there's a capacitor here. I don't see any feedback on this at all. So let's just go through and check some of these components. Okay, we're on ohm meter. We're going to check the fusible resistor. 10 ohms. Okay, we're good there. Let's go diode check. Well, I'm assuming the bridge rectifier is good because the resistor didn't blow. If the bridge rectifier shorts, that's the first thing that's going to go is that fusible resistor. So this is looking promising if we have fusible resistor didn't do anything. But I'm going to check the bridge anyway. There's 1, there's 2, there's 3, and 4. Everything's good on the bridge. We have a diode here. Let's check this. That one's good. Let's check the diode on the output. It looks like it's under a lot of stress and heat. Ah, shorted. Okay. Got nothing there. So we definitely need to replace that diode on the output. Okay, let's get an ESR meter and check some of these caps. Okay, for the output capacitor, let's check an ESR, and we have 0.06, which is pretty damn good for a 470 microfarad. We have a 10 microfarad 50 volt. .3, which is probably right on the line where it's supposed to be, yeah, so we're okay with that one. Check the main filter capacitor for the input side, and what do we got? 12. Okay, so 4.7 should be a lot less than 12. It should be under 5. So that cap I'm going to replace. and we have to find a diode. I got one more diode here I didn't check. Let's check that one. This diode. Okay, that diode's good. So everything looks good on the primary side, except for that cap. What looks like it happened is this diode roasted, and it got overheated and it shorted. And that killed the output altogether. So let's replace that diode and see what part number we have on it. Maybe it's a special high speed thing. I have to remember its orientation. Oh yeah, there is a mark on the board. Okay, this is a what is this? SR240. SR240. Now I'm assuming since this is rated at 1500 milliamps, we're going to need a diode that's capable of at least 2 amps. So I'm going to look this up, this SR240, and see what specs we have on it, and see if I can find a good substitute. Alright, so here's the main filter capacitor on my LCR bridge. It is measuring 3.7 microfarads. It's down 1 microfarad from 4.7. ESR of 18 ohms. ESR should somewhere be less than 10. I'm not going to monkey around with this capacitor because I don't have a replacement. Well, I do, but I don't. I'll show you what I got here. This is a replacement capacitor. This is a 4.7 microfarad at 250 volts, and you can see the ESR drop quite a bit. Now this capacitor will work in the circuit, but it's only a 250 volt capacitor compared to the original was a 400 volt. Now for where I live in North America, that's not a problem because this capacitor would never see more than 170, 180 volts during its lifetime. The problem exists if I went traveling and I took this adapter and tried plugging it into a 220 or 240. It would immediately pop that capacitor and probably short the bridge and destroy that fusible resistor. So that's the reason why it's a 400 volt, just so it has that wide voltage range. Now the diode I pulled out, the shorted diode on the rectifier on the output, the one I pulled out is an SR240, and I looked up the specs on this, and it is a 2 amp 40 volt Schottky diode. And that's important because it has to be an efficient diode. In a switch mode power supply, you want an efficient diode. You just can't slop a regular silicone diode in here because it wouldn't operate at the same efficiency. And probably what would happen is as soon as you start getting around 1 amp, 1.5 amps, it would be so inefficient that it would overheat and short out again. So that's why they put a Schottky in there. But I couldn't find anything suitable. What I did find is I have a power supply from a server, and it had some nice surface mount diodes on here, and I picked one off in particular that I'm going to use. This is a U3J from onsemi. It is a 3 amp 200 volt diode, and this is fast recovery. So this will work perfect in this application of rectifying the output. And it's a surface mount, so I just have to mount it on the back side instead of through hole. So it'll mount something like that, and it should perform ideal. It's a 3 amp diode. It should last forever. There's no problem with that. So let's solder that on. Let's see here. I got to get the polarity right. It is marked on the board here. So it would go like this. And let me get my soldering iron going. I gotta make sure it's centered on the holes. And of course it wants to lift off. Here, let me solder. I can't. Getting a little hot on the fingers. Yeah, it is. Okay, I got one side done. Other side's done. I just want to make sure it fits in the case. Where is the case? Yeah, it's in no problem. Lots of room. So there, diode's installed. You can see that. Here's where it was originally. So see, it's all burnt. And on the other side, we got a 3 amp diode there. And that'll do the business. Alright, so the rest of this is just putting it back together and testing it out. Okay, I'm going to test this out now. And I have my Widowmaker. You know what that is. It's a cord with alligator clips on the end. I'm going to plug this into my isolation transformer, and we are going to clip it on the input. And then we're going to attach our USB charge doctor, and we're going to turn it on, see if it works. Doors pop. Yeah, look at that. We have power. We've got 4.5 volts. So it's working. Okay, what I want to do What I want to do is I want to measure that voltage across that main filter capacitor to show you that although it's a 400 volt capacitor, you'll never see that high a voltage in North America. So turn the power on. We got our voltage going. Let's touch these probes and see what kind of voltage we get. And 150 volts, which is reasonable. Let's try a little higher voltage. What's my voltage on the input? Yeah, we're only at 108. Let's turn this up. What do we got now? There we go, 120. Across the filter cap, we should have 170, 165, 166. So everything's perfect. Shut the power off. Get rid of this death thing. Okay, we're ready to reassemble this because it's finished. Now I could glue this. Let's just try snapping it in. I got upside down. Yeah, I think I'll glue it in just to make it safe so it doesn't fall apart. So there it is. We're done. Got a working charger again. Now maybe you're asking, why would I bother fixing a charger like this? Because you know, you buy them anywhere, you get them anywhere, and they're just cheap. But you know, it was educational. Learn a bit from how they work and how to repair them. And what if you're stuck and you don't have a charger? You're up on the North Pole in the Arctic expedition, and your charger goes out, and you got to fix it. So yeah, it's good to know. All right, thanks for watching.